Hi everyone, welcome back to our channel. Today we are going to find the theoretical calculation for the given network using Thevenin's theorem. So here he is asking us to find the value of IL flowing in the load resistor of 50 ohms. So the formula to find Thevenin's theorem is, so first we need to find out the voltage source, which is nothing but V Thevenin, and we need to find out the next step is nothing but R Thevenin and replace with the given load. So the given load resistor RL is equal to 50 ohm, and in this branch we need to find out IL. Okay, so the formula for IL is equal to, okay, so just it's very simple. This is V Thevenin, so IL is equal to the current is flowing in this direction, so this is high potential, so V Thevenin minus 0 divided by R Thevenin plus R. RL is how much given in the problem is 50 ohm. So first we have to find out VThevenin, and second we have to find out RThevenin. So here you can see here the type of source given is an independent source. So first step is finding out VThevenin. VThevenin is also called as open circuit voltage. The process of finding VOC is first remove the load resistor. Okay, so we have to remove the load resistor. So how to remove the load resistor is just remove the load resistor. Okay, so we need to remove the load resistor. Whenever you remove the load resistor, here you can see here. So we have to remove the load resistor. So this will be acting like a 30 volt source, and this will be a 500 ohm resistor, and this will be a 100 ohm resistor. Okay, so when you make it open circuit, okay, so this is open circuited, and this open circuited branch we have to find out the open circuit voltage, where this voltage is called as open circuit voltage. Okay, so we have to remove the load resistor. As soon as you make it open, then automatically when you make it open, current is 0, only voltage is available, where this voltage is called open circuit voltage. So remove the load resistor and find the voltage across the resistor. The voltage across this and the voltage across this both are same, so this is how we are going to find out VOC. Okay, so now how to find VOC is open circuit voltage. Already one voltage is known, and these two resistors are connected in series. So we can find out VOC by using voltage division rule. Okay, so as per the voltage division rule, so voltage division rule is total voltage. Total voltage is 30. VOC is the voltage across which resistor? 100 ohm. So what is the value of the resistor where we record the voltage is 100. So multiply with the same resistor divided by the sum of resistors which are connected in series. The sum of resistors is 500 plus 100. So where it is going to get the voltage of 5 volts. Okay. So just remove the load resistor. As soon as you remove it, it will act as an open circuit. In open circuit, what will be there is only open circuit voltage that we have been find out. So this is method 1 of finding VOC. Let's try to verify with another method whether what done is correct or not. Okay, so I'm going to mark this current as two currents, this current as some I1 current, and this current as some I2 current. So try to apply KCL at the node VOC. Apply KCL at the node VOC. Okay, here you can see here no current is entering. Entering currents are 0 and the leaving currents are I1 plus I2. So 0 is equal to I1. How to write down the current I1? So the current I1 is flowing like this. Okay, so this is nothing but plus VOC, VOC, and what is the leaving terminal of the voltage? Minus 30 divided by R. What is the value of R? Which is nothing but 500. So how to write down the current I2 which is flowing in this branch is VOC. VOC is how much? VOC minus 0 divided by R is how much? 100. Now let's try to find out VOC. This I can write down it as 30 divided by 500 is equal to, take VOC as a common term. When you take VOC as a common term, which is 1 by 500 plus 1 by 100. So automatically just use your calculator. You will also get same VOC, or the value of Thevenin's voltage is equal to 5 volts. So you can see here by method 1 or method 2, ultimately the voltage obtained from Thevenin's by removing the load resistor and finding the voltage, you are going to get it as 5 volts. And second step is finding R Thevenin. Okay, so how to find out R Thevenin for this problem? Okay, so very simple. So the formula for finding R Thevenin is very simple. So the second step is R Thevenin is first remove the load resistor. Remove the load resistor and find the, so just remove the load resistor, and if you have any voltage source, what is the voltage source given? Voltage source is 30 volts. Deactivate this voltage source. Deactivating this source means we have to make this voltage source as 0. So this voltage source is 0 means we have to make it as an short circuit. So deactivate the voltage sources and current sources, and you can see here, so remove the load resistor and resistance seen from the open circuited terminals. Okay, so now this source is short circuited and we are having an 500 ohm, and here we are going to have an 100 ohm. So this is a 100 ohm resistor, this is a 500 ohm resistor, and we have been removed the, so the process is remove the load resistor. First remove the load resistor. Okay, so remove the load resistor and the resistance find from the open circuited terminal from this side. Okay, so therefore you can see here the current flows and current is going to divide. Whenever the current is divided, these two are connected in parallel. Okay, therefore between this node and this node you are going to get only one resistor, where this is the resistance obtained by removing the load resistor and seen from the open circuited terminal. So 500 and 100 are connected in parallel. So product of resistors divided by some 500 plus 100. So when you do it with your calculator, then you are going to get this value is 83.33 ohms. Okay, so now just substitute here. So Thevenin's value we obtained here is 5 divided by R Thevenin value is 83.33 ohms plus 50 ohm. So what is this 50 is already given as RL. When you do it, then you are going to get 37.5 milliamperes is the current what you are going to get. So as per the given problem, the load current you are supposed to get is 37.5 milliampere. So those who get confusion, just watch more videos in my channel on Thevenin's theorem, then you can understand well. Okay, so first the process of doing is first remove the load resistor. As soon as you remove it, automatically it will act as an open circuit. In open circuit only voltage will be there, then you are going to find out VOC. And the next process of RThevenin is, if any voltage source is there, short circuit the voltage source and remove the load resistor, the resistance seen from open circuited terminal, then you are going to get RThevenin. That's very simple. Okay, so if you solve, you can solve more problems on this independent, and dependent. So then you can have more knowledge on Thevenin's theorem. So this is the theoretical calculations regarding Thevenin's theorem. If you feel my video and explanation is good, please like the video and share with your friends. And if you have any doubts, let me know in comment section. I will answer your doubts. And if you are watching the channel for the first time, subscribe to my channel with the name KVThulasiEVCrush. So kindly support this sort of a free channel for the development of students and faculty. Thank you for watching. We'll meet in another good problem. Yours, Ram.